For this section, I'm going to begin talking to you about some properties of exponents. The first property we have is called the product of powers, and the general rule looks like this. If you have a quantity like a raised to the m power, and you're taking it times a raised to the n power, so notice that they have the same base, they're both base a, we have to add those exponents, m plus n. So some examples of this, if we had 3 squared times 3 to the third power, we would take 2 plus 3 in those exponents and be left with 3 to the fifth power. Now since we can actually evaluate this, we would go to our calculators and type in 3 to the fifth power, and we would get 243. If you have just letters, like I showed you in the rule up above, but let's say we have x squared times x to the third. Same rules apply. You're going to add the 2 plus the 3, but this time we're going to have to leave it at just x to the fifth power because we don't know what x is. The next rule we have is the power of a power. So for this one, you'll have a quantity like that a to the m power, but this time that's in parentheses and it's raised to the n power. So slightly different than the first one, and what you're going to have to do is take m times n. So instead of adding, you'll multiply. For example, if you had 3 squared, then that's raised to the third power. You're going to multiply those exponents, 2 times 3, and be left with 3 to the sixth power. And again, since we can simplify this one, we will, and we'll get 729. For a letter, like x squared to the third, the same rule applies. You multiply those exponents, and you're going to be left with x to the sixth power. The last property in this section I want to go over is the zero power property, which says that anything raised to the zero power is always equal to 1. So for example, if I had 3 raised to the zero power, that's going to equal 1. If I had x raised to the zero power, that's going to equal 1. For this first example, I would start by multiplying my 3's. 3 times 3, which is 9. Now for my exponents, this first one has just a letter by itself. It technically has an exponent of 1. So for the n's, you're going to do 1 plus 2 plus 3. So this is going to be 9, and then n to the sixth power. For number 2, again, I would start by combining the 4's. 4, 4, and 4 is going to be 64. For my q's, this is q to the first power. So I would have q to the first power plus 3 for the q to the third in the last term. For my m's, I would have a 4 plus a 2 plus a 3. And for the p, I would have a 3 plus nothing, because this p to the 0 is going to become a 1, and the last term doesn't have a p term. So to simplify, we would have 64 q to the fourth, m to the ninth, p to the third. For this next one, because it's the power of a power property, this 3 on the outside is going to apply to all the terms on the inside. So you're going to have 3 to the third power, y to the third power. The x to the 0 becomes 1, so you don't have to do anything with that. The last thing is 3 to the third is going to be equal to 27, and then you have y to the third power. If you want to take a few minutes, go ahead and try these next two problems, pause the video, and when you're ready, come back through and I will do a quick walkthrough of both of them. For number 4, you need to rewrite this so that it's 2 to the fourth power x to the 16th y to the 12th times 2x to the 4th. So you're going to end up with 2 to the 5th power, x to the 20th, y to the 12th. And 2 to the 5th power is going to be 32. Then you have x to the 20th, y to the 12th. And for the last one, number 5, you will have m to the 12th, n to the 12th, times 2 to the 3rd, n to the 3rd, m to the 12th. 2 to the 3rd power is going to be 8. Your m is now going to have an exponent of 24, and you'll have n to the 15th power.